Hello viewers, I'm Kausalya. Today we are going to solve problems in two-port networks. The problem is find the driving point impedance for the network shown below. So here this is the given circuit diagram. We are going to calculate the impedance. So here in the given circuit, you see the resistors are mentioned in ohms and inductors are in Henry, but we always need the answer in S domain. So here you see I am redrawing the circuit diagram, and here 1 by 3 H I had modified this as 1 by 3 S. Now we are going to calculate the impedance. Since the circuit is simple, so what is the basic formula? V is nothing but I into R. So here we are having, as we are having inductance and resistors together, I am writing it as I into Z. Therefore, what is the value of Z? Z is nothing but V by I. Right. So we cannot directly substitute the values, as we have both inductors and resistors here. So first we are going to calculate the value of this impedance. So how to calculate the impedance? You see, this is the source voltage and this is the direction of the current. So at this node, what happens? The current divides into two. So whenever the current divides into two, what does it mean? That is, this resistor and this inductor are connected parallel. So what is the formula? So here the thing is R1 into R2 divided by R1 plus R2. So here the value of R1 is 1, and what about the value of inductance? Here it is S by 3. So R1 into R2 divided by R1 plus R2. So 1 into 1 by 3 S gives S by 3, and here you have to take LCM as you have plus here. So it becomes 3 plus S by 3. So again this 3 and 3 they cancel each other, and finally here we are having S by S plus 3. Now I had combined this resistor and inductor together. Now that combination will be connected in series with this 1 ohm resistor. So here the total impedance is 1 plus S by S plus 3. So here again we have to proceed with LCM. So once you take LCM, 1 into S plus 3 becomes S plus 3 plus S divided by S plus 3. So again S plus S makes 2S. Therefore 2S plus 3 by S plus 3, and finally here we are going to calculate the value of this impedance. So just I had written numbers first, proceeded by the S term. Okay, here both way of writing is correct. So finally this is the driving point impedance for the given network. Now we will proceed with our next problem. So here the problem is find the driving point impedance for the network shown in figure. So again this network consists of both resistors and inductors. So what is the primary step? So here we have to convert this inductor in the form of S. So here you have to add an S to these values. So 1 into S, again here 1 into S. So when you redraw the circuit, you see this is how our circuit is. 1 ohm, 0.5 ohm, here S, and here also S. So again here we are going to calculate the value of the impedance. So we will start from here. This is your source, and here is the flow of current I, and this current at this node it gets divided into two. And again the current flowing through this inductor, when it reaches this node, it gets divided again. So what happens here? Here these two resistors, this resistor and inductor are connected in parallel because the current gets divided. Therefore first we are going to find the equivalent impedance of these two things. So here the value of impedance is again R1 into R2 divided by R1 plus R2. So here it is 0.5 into S divided by 0.5 plus S. So here this is the value of the impedance. Now again when you look back, you see now I had resolved these two things into a single element. Now that element comes in series with this inductor. I hope you people can understand. You see, this is this inductor S. Now I had converted these two things into a single element. So here comes that impedance. So what is the value? So this is the value of impedance that we had calculated. Now these two elements are in series connection. So this combination is in series with S. Therefore S plus the value of impedance is 0.5 S divided by 0.5 plus S. Now we have to take LCM. So once you take LCM, here you see this term gets multiplied with s plus 0.5 s divided by 0.5 plus s. So again when you multiply, you see 0.5 into s, 0.5 s into s square. So here you see 0.5 s plus 0.5 s, they make 1 s. Therefore, s plus s square divided by s plus 0.5. So this is the value of the impedance. Now the calculated value of impedance is in parallel with the 1 ohm. That is, wait, let me show you. You see, now I had combined these two elements and that impedance is combined with this element. Now this total net impedance is in parallel with this 1 ohm resistor. Therefore, so here this 1 ohm is in parallel with this calculated impedance. So Z1 into Z2 divided by Z1 plus Z2. So as per the formula, just multiply, and here for this denominator part you have to take LCM. So once you take LCM, the whole term will be divided by s plus 0.5. Now you can cancel the denominator terms of both the numerator and the denominator part. So here the value of impedance is finally s plus s square divided by s square plus 2s plus 0.5. So this is the value of driving point impedance of the given network. So the same problem can be solved by using mesh method. So here you see we are going to write everything in the form of matrix. So here the basic formula is V is equal to, here it is Z and here it is I. So again when you look back at the problem, so how many loops do you have? Totally we are having 3 loops. 1, 2, 3. So now we are going to write these values in the form of matrix. Therefore, we have to frame a 3 by 3 matrix for impedance. So what about the voltage source? We are having only one voltage source. That too the voltage source belongs to the first loop. So while writing, so here we had written as V1 0 0 because second loop and third loop doesn't have a voltage source. So which is equal to, what about the value of impedance? So again, so V1 is available only for this first loop. So there is no voltage sources in loop 2 and loop 3. Therefore, here it is 0. And the next thing is calculating the value of the impedance. So when you look at the first loop, I am having only 1 ohm. So here it is 1. When you look at this second loop, so here totally I am having 1 plus 0.5 plus s, right? So 1 plus 0.5 makes 1.5. So 1.5 plus s. And finally, when you look at this part, s plus 0.5, right? Now we are going to find the common terms here. So now for this loop 1 and loop 2, what is the element which is common? This 1 ohm is common. So here current flowing through this loop 1 is in this direction and current flowing through the loop 2 through this 1 ohm resistor is opposite to it. Therefore here the value is considered as minus 1, right? This is 1. Why minus? Because the current flowing through this 1 ohm is opposite to each other. So here it is minus 1. So here it is minus 1. And between first loop and third loop, there is no common element. Therefore, here it is 0. So here also 0. Again, when you look at this 2 and 3, this 0.5 ohm is common. And again, the current flowing through this 0.5 is opposite to each other. When you took loop 2, it flows like this. When you took loop 3, it flows like this. Therefore, they are opposite to each other. So here we are including a minus sign. So minus 0.5, here minus 0.5. So once everything is done, we are calculating the value of del. So del is nothing but finding the value of this impedance matrix, right? We are calculating the determinant. So how to calculate the determinant? I believe you people will remember all these things. So when you take the determinant, the value of del is calculated as s plus s square. Now we are going to calculate the value of del 1. So how to take del 1? So del 1 value is, we are going to remove this column and I have to replace these values by this value. So here comes V1 0 0 and the rest of the things they remain the same. So again when you take the determinant, the value of this del 1 is calculated as V1 into 0.5 plus 2s plus s square. So this is the value of del 1 and this is the value of del. So now I am going to calculate the value of I1. So I1 is nothing but it is del 1 by del. So this is your value of del 1 and this is the value of del. So you see here I have I1, here I have V1. So now I am going to reframe this expression in the form of V1 by I1. So I am going to move this I1 here and I am going to move these remaining terms to the left hand side. So here the value of impedance, that is the value is s plus s square by 0.5 plus 2s plus s square. So V1 by I1 is nothing but Z1 or Z. So finally the value of driving point impedance is s plus s square by 0.5 plus 2s plus s square. You can calculate in any method. It's up to you. So that's all. If you have any doubt, let me know in the comment section. Thank you.